Years before the flight, engineers decided that the Boeing 747-400's lower rudder could be driven fully to its limit by hydraulic pressure alone, without a mechanical stop to block a sudden, uncommanded move. That design choice meant that if a single servo valve jammed, the rudder would swing hard left or right with no warning. On October 9, 2002, Northwest Airlines Flight 85 left Detroit for Narita, carrying passengers and crew across the Pacific. 7 hours out, over the Bering Sea, the aircraft was at 35,000 feet when the lower rudder slammed to its full left position. The rudder is the vertical tail surface that swings left or right to yaw the nose. On the 747, it is split into upper and lower sections, and the lower half had just deflected without any pilot input. The sudden yaw rolled the airplane into a 30 to 40 degree left bank. Junior Captain Frank Jabe, who had just taken the controls, first thought an engine had failed. Senior Captain John Hanson returned to the cockpit, and together with First Officer Mike Fagan, they fought the roll. They applied full right upper rudder and right aileron to oppose the left yawing force, and they added asymmetric thrust, more power on the right engines, to keep the wings level. Even as they struggled to maintain control, the crew tried to declare an emergency. They were in a communications dead zone between continents. Their weak signal reached another Northwest flight, Flight 19, which relayed the Mayday call to air traffic control. A conference call with Northwest's maintenance center in Minneapolis, St. Paul, produced no quick fix. None of the existing emergency procedures could counteract the hard-over rudder. The pilots flew the aircraft manually, using a combination of rudder, aileron, and engine thrust, and diverted to Ted Stevens Anchorage International Airport. They landed safely. No one was injured. Captain Hansen later said the outcome showed classic crew resource management. We were blessed and lucky that we had full flight crew augmentation. We had 4 pilots to work together in the cockpit. We had an excellent group of flight attendants on board. The investigation traced the hardover to a fatigue crack in the servo valve that controls hydraulic pressure to the lower rudder. The crack allowed the valve to stick, sending unrestricted pressure that drove the rudder to its stop. As a result, the Federal Aviation Administration issued an airworthiness directive requiring repetitive inspections of the rudder power control unit servo valves, and if necessary, their replacement or redesign to add redundancy and mechanical limits. That single design decision, relying on hydraulics alone to position the rudder without a hard stop, had set the stage. When a tiny crack formed in a valve, it took a chain of small failures, a stuck valve, an uncommanded rudder, a loss of automatic yaw damping, to create a crisis that only skilled crew work and quick thinking could avert. The directive that followed changed how the 747-400's rudder is maintained, ensuring that a similar jam cannot again force the rudder to its limits without detection.